Hey guys, so in this series we will talk about the new NavMesh system that is included in Unity 6, and in this series we'll go through all of its features, all of the components and all of the different settings each components have. And today we will focus on the NavMesh surface component that you can see here. Now the AI system is not included in Unity by default, not included in the editor since Unity 6, and you need to add it from the package manager, which you can find under Window, Package Manager, Unity Registry. You need to search for AI and need to add it. You can click AI and there should be an install button somewhere. Now I already have it, and that's why I have the remove button. So after you add it to your Unity, how to bake a surface, how to bake actually anything to be usable for the AI, you need to add a component anywhere in your scene. The component that you need to add is NavMesh surface, and you need to click bake. Now, in this particular video, we will talk about only the NavMesh surface, and in the next ones, we will talk about the other components that can be used for this AI navigation system. The first settings is agent type. So agent type is basically a set of settings that are used to bake this specific surface. For example, as you can see, we have here two slopes. This is 45 degrees and this is 30 degrees. Now both of them are walkable because here in the agent settings, which you can also find here, open agent settings, the slope is set to 45 degrees. Now if I would lower this to, let's say, 11.5 degrees and I bake the scene, you can see that these two slopes are not walkable anymore because these are the settings that I used for baking the NavMesh surface. So I put it back to 45 and bake it again. The next settings is the default area, which defines the costs of each area, but I will explain it. Already included are three area types. These are included by default in this navigation system. One is walkable, not walkable, and jump, and you can add up to 31 areas. Now each area has a color, a name, and a cost. Now for this demonstration, I created one, called it water, and I added a cost of 5. Going back here on the NavMesh surface, the default area is walkable. And I also added a different area using the NavMesh modifier volume component, and I set its area type to be water. Now, how this AI system works, if I want to move, this is the NavMesh, sorry, the navigation agent, which is the brain of the AI. If I want to move this AI from point A to point B, it will always move on the areas which has the least amount of cost. So if I click play, and I want to move this agent to here with a click of a button, you can see that it will avoid the water. Why? Because the water, going back again to the water, because the water has an area type of water and its cost set to 5. The default area for this NavMesh surface is set to walkable and it has a cost of 1. So it means that it's 5 times more costly to walk on the water or through the water, whatever, than to go on the walkable surface. So the AI would then prefer this route because it's less costly. So this can be used for setting up waters, places with tall grass, swamps, and whatever. So this is where you use the area feature. Generate links. So in this example, I already have this big platform and two small ones. Now, if I want this agent to walk from the big platform to the small one, by the way, which are not connected, that I cannot do it because they are not connected. And what I need to do to let my AI to jump from one platform to the other is I need to enable generate links. So if I enable this, here you should see an indicator showing that the AI can jump from one platform to the other. Now we don't see it for obvious reasons, is because the humanoid in the agent settings has a jump distance of 0. I need to change it to 5, or at least a higher value. And when I bake the NavMesh again, you can see that now these indicators are showing that the AI can go to that platform. So if I click on this platform, once Unity loads finally, then you can see that the AI can move to that platform. The next thing is use geometry. This is very straightforward. Defines when you bake the NavMesh surface, it defines what kinds of objects are included in the baking process. We have two options, one render meshes and one physics colliders. Render meshes means that every object that has a render mesh component on it will be included in the bake process. The other says that objects that has physics colliders will be included in the bake process. So for a quick demo, here we have one object that has only a mesh renderer, and there is another which has the mesh collider on it. Now as you can see, this one has an NavMesh surface on it, so it's baked correctly because we have the render meshes option chosen, and the other one doesn't have a NavMesh surface. But if I change to physics colliders and bake again, you can see that this one, this one which has a mesh collider on it, now it's included in the baking process, and the other one is not. This big platform did not change because it has a mesh renderer and a mesh collider, so either option you choose, it will be added all the time. Object collection. In the previous versions of Unity, you had to choose, so if you wanted to select which kind of objects are included in the baking process, you need to select those objects, and here on the top right, you had to mark them as navigation static. Now that's also changed because that's not how it will work. You need to select what objects you want to include from these options. The first one is all objects, which means it will include every object. The other is a volume. There you have a volume that you can modify, you can increase it, and everything that is included in this volume will be added to the baking process. For a demo, I will make it a bit bigger. So everything that is included, not the whole object will be included, but only the area that is covered by the volume. Current object hierarchy, this is my preferred method because it includes the current object, meaning that the object which has the component and all its children. The other is NavMesh modifier component only, which uses objects that has a NavMesh modifier component on them. Yes, going back. The second option that you can use is the layers which are included. If I put maybe nothing and UI and I click bake, then only objects that has a layer of UI are included in the in the building process. Let's put it back to everything, advanced. So in the advanced section, you can define the voxel size and the tile size. So the voxel size means how many voxels are included into an agent's radius. And this is used for tight spaces, tight spaces like this one and this one. This would be, well, I'm not a designer, but this should be a door and a room. And as you can see, the path is very chunky. Now, if you don't want to use it like this, you can decrease this number, which means that more voxels are included inside the radius of an agent. And if you click bake, you can see now that the area is baked with a lot smoother edges, so the navigation itself will look a lot smoother. So this is where you use it, and also here you can see there is a difference, not much, but it's mainly used for narrow pathways. Override tile size. So the tiles, so the baking is grouped into tiles, meaning that all this big surface is divided into tiles. Now the tile is too big, that's why I don't see it. If I change it to 16, you will see now the tiles. These are the tiles marked with white squares. Now what's the use case of this? For example, if you have an object that is dynamic and it changes the navigation surface, like this one, and you change it during runtime, maybe it's a barrel that you can kick and it will move around. Then if it moves from this position to that position, then the navigation surface has to be rebaked. And how the rebaking works is that it will rebake only the tiles that has some changes. Now in this case, because we are using small tiles and the tiles are themselves, I small, to repeat myself, then it means that only this area has to be rebaked. The other areas remain the same if I move this game object during runtime and rebake the mesh, the NavMesh. But if I use bigger tile sizes like 50 and I move this object from here to here, even though the movement itself is very small, only covers this area, the whole tile has to be rebaked. So this is very inefficient if you are using dynamic objects that affect the navigation surface. Minimum region area. This one is set to 2 by default, which defines the minimum area, the minimum size of an area that is included in the navigation. So if I change it to a bigger number, then you will see that these platforms will be not included. It will not be navigable, let's say. I'm not sure if that's a word, but you will get my point. Build height mesh. So this one is very simple and Unity has already some demo for it, so I will just use it from them. The left platform doesn't have build height mesh enabled and the right one has. That's why you can see this peak indicator which indicates the height mesh. What it does is calculates also the height of the navigation surface very precisely. And in this demo you will see that this agent, when it travels on the stairs, it will travel as it would be a slope, and this agent will travel through each of the steps, changing its height. So this is the use case for height meshes. So yeah, that's it for this video. We covered all the features, all the options of the NavMesh surface. In the next videos of this series, we will go through the other components and each of them will be explained and demonstrated. Thank you.